So the last lecture we saw how to read and write text files. And reading and writing text invariably involves processing the strings that we read and write. And so Python has a number of string processing functions that make it easier to modify these contents. So usually you're reading and writing files in order to do something with these files. And to do something with these, you can use the built-in string functions, which are quite powerful. Among other things, what you can do with these string functions is, for example, search for text or search and replace it. A typical use of string processing for a file is when we take something like a spreadsheet and export it as text. So there is something called a comma separated value format, CSV, where the columns are output separated by commas as text. So now what we can do with the string file is to read such a file line by line, and in each line extract the columns from the text by reading between the commas. So we will see all these in this lecture. So the first example of a string command that we already saw last time is the commands to strip white space, right? So we have rstrip, which we used, for example, to remove the trailing white space, the backslash ends in our lines, and we had lstrip to remove leading white space, and we had strip, which removes it on both directions. So let's see how this works. Let's create a string which has white space before and afterwards. So let's put some spaces, maybe a tab, then the word hello, then two tabs. Okay, so we have a string which has white space, and you can see the tabs are indicated by backslash t and blanks. So now if we want to just strip from the right, we say t is equal to s dot rstrip. So remember, this strip command, the strings are immutable, right? So it won't change s, it'll just return a new string. So if I say t is s dot rstrip, it will strip the white space to the right and give me t. And if I look at t, it has everything up to hello, but not the tab and the space afterwards. Similarly, if I say t is s dot lstrip, it will remove the ones to the left, and now t will start with hello, but it will have the white space at the end. And finally, if I say t is s dot strip, then both sides are gone, and I will just get the word that I want. So this is useful because when you ask people to type things in forms, for example, usually they leave some blanks before and after. So if you want everything before the first blank to be lost and the last blank, and only keep the text in between, then you can use a combination of lstrip, rstrip, or just strip to extract the actual data that you want from the file. So the next thing that maybe I want to do is to look for text in a string. So there is a basic command called find. So if s is a string and pattern is another string that I'm looking for in s dot find pattern will return the first position in s which pattern occurs. And if pattern doesn't occur in, so the position will there obviously be between 0 and the length of s minus 1. We already wrote our own implementations of this earlier, right? So if it doesn't occur, it will give you minus 1. Now sometimes you may not want to search the entire string, so pattern takes an optional pair of arguments start and end, in which case instead of looking for the pattern from the entire string, it looks at a slice from start to end with the usual convention that this is the position from start to end minus 1. And there is another version of this command called index, and the difference between find and index is what happens when the pattern is not found. In find, when the pattern is not found, you get a minus 1. In index, when the pattern is not found, you get a special type of error, in this case a value error. So again, let's just see how these things actually work. So we have a string here s which contains the words brown fox, grey dog, brown fox. Now if I ask it to look for the first occurrence of the word brown, then it will return the position 0 because it's right there at the beginning of the string. If on the other hand I don't want this position, but I want it, say, starting from position 5 and going to the length of s, for example, then it will say 19, and if you count, you will find that the second occurrence of brown is at position 19. If on the other hand I look for something which is not there, like cat, then find will return minus 1. So minus 1 is the error, which is, or not the error, but the indication that the string was not found. Now difference with index is that if I give index the same thing, instead of a minus 1, it gives me a value error saying the substring does not occur. Right? So this is how find and index work. So the next natural thing after searching is searching and replacing. So if I want to replace something, I give it two strings, what I'm searching for, and what I am replacing it with, and it will return a copy of S with each occurrence of the first string replaced by the second string. Now this can be controlled in the following way. Supposing I don't want each occurrence, but I only want, say, the first occurrence or the first 3 occurrences. So I can give it an optional argument saying how many such occurrences starting from the beginning should be replaced. Right? So it says replace at most the first n copies. And notice that, like in strip and all that, here because it's changing the string, it's replacing something by something else. It's not that S is going to change because strings are immutable. It's going to return us the transformed string. So let's look at an example. Once again, let's use our old example. S is brown fox, grey dog, brown fox. And now supposing I want to replace brown by black. Okay, then I get black fox, grey dog, black fox. If I say I only want one to be replaced, then I get black fox, grey dog, but the second brown is left unchanged. Now, you may ask what happens if I have this pattern, it doesn't neatly split up. If I have the different copies of brown overlap. So supposing I have some stupid string like A, B, A, B, A. And now I say replace all A, B, A's by say D, D. Right? So now the question is, will it find 2 ABAs or 1 ABA? Because there is an ABA starting at position 0. There is also an ABA in the second half of the string starting at position 2. The question is, will it mark both of these and replace them by DD? Well, it doesn't, because it does it sequentially. So it first takes the first ABA, replaces it by DD. At this point, the ABA, the second ABA has been destroyed. So it will not find it. Okay? Whereas if I had, for instance, 2 copies of this disjoint, then it would have correctly found this and given me DD followed by DD. So there's no problem about overlapping strings. It just does it from left to right, and it makes sure that the overlapped string is first written, so it will not, the second copy will not get transferred. So the next thing that we want to look at is splitting a string. Now when we take a spreadsheet and write it out as text, usually what happens is that we'll have an output which looks like this. Okay. So the first column would be written followed by a comma, then the second column. So if we had 3 columns and the first column said 6, second column said 7, and the third was a string hello, then when we write it out as text, we will get 6, 7, and hello. So actually hello is a bit of a problem because it has double quotes. So let us not use hello. Let us use something simpler. So let's just say that we had 3 numbers, okay, 6, 7, and 8, for example. Now, what we want to do is we want to extract this information, right? So we want to extract the individual 6, 7, and 8 that we had as 3 values. So what we need to do is look for this text between the strings. So we want to split the column into lines into chunks between the commas, and this is done using the split command. So split takes a string S and takes a character, or actually it could be any string, and it splits the columns. It gives you a list of values that come by taking the parts between the commas. So up to the first comma is the first thing. So columns is just the name that we have used. It could be any list. Okay, so the first item of the list will be up to the first comma, then between the first and second comma, and so on, and then finally after the last comma. So comma in this case is not a very special thing. You can split using any separator string. And again, just like in replace, we could control how many times we replaced. Here you can also control how many splits you make. So you can say split according to this string. So notice that this could be any string. So here we are splitting it according to space, colon, space, right? But we are saying don't make more than n chunks. So if you have more than n columns or whatever chunks which come like this, beyond a certain point, we will just lump it as one remaining string and keep it with us. So again, let's see how this works. So suppose this is our line of text, which I call CSV line. It's a sequence of values separated by commas. Notice it is a string. Okay. So now if I say CSV line dot split using comma as a separator, then I get a list of values: the string 6, the string 7, the string 8. Remember, this is exactly like what we said about input. It doesn't get you the values in the form that you want. You then have to convert them using int or these are still strings. So it just takes a long string and splits it up into a list of smaller strings. Now here there are 3 elements. So if I say, for example, I only want, so position 0, 1, 2. So if I say I only want you to do it once, then I get the first 6, but then 7 and 8 doesn't get split because it only splits once. Okay? Now, if I change this to something more fancy, like say hash question mark, right? So now I have a different separator. It's not a single character, but hash question mark. Then I can say split according to hash question mark. Okay, and this will give me the same thing. So you can split according to any string. It's just a uniform string. There are more fancy things you can do with regular expressions and all that, but we won't be covering that for now. As long as you have a fixed string which separates your thing, you can split according to that fixed string. So the inverse operation of split would be to join strings. So supposing we have a collection of strings and I want to combine it into a single string, separate each of them by a given separator. So as an example, supposing we take S, which is some CSV output, and we split it into columns on comma, then we can take join string and set it to the value comma and then use that to join the columns. Now this is a bit confusing. So join is a function which is associated with a string. In this case, the string in concern is a comma. So it says, more or less you're saying comma dot join columns, which is use comma to join columns. Right? So you've just given it a name here, join string is equal to comma, and then CSV line is join string dot join columns. So what this says is use comma to separate. So if at the end of this I had got, like last time, 6, 7 and 8, then this will now put them back as 6, 7, 8 into a single string. Okay. So here is another example. Here we have a date 16, a month 08, and a year 2016 given as strings, and I want to string it together into a date like we normally use with hyphens. So here, instead of giving an intermediate name to the hyphen and then saying hyphen dot join, I directly use the string itself. Just want to illustrate that you can directly use the joining string itself as a constant string and say use this to join this list of values. Right? So all you need to make sure is that what you have inside the join, the argument, is a list of strings, and what you apply it to is the string which will be used to join them. Okay? So let's just check that this works the way we actually intended to do. So let's directly do the second example. So supposing we say date is 16, remember these are all strings, month is 08, year is 2016, and now I want to say what is the effect of joining these three things using dash as a separator, and I get 16-08-2016. So there are many other interesting things you can do with strings. For example, you can manipulate uppercase and lowercase. Okay, so if you say capitalize, what it will do is it will convert the first letter to uppercase and keep the rest as lowercase. If you say s dot lower, it will convert all uppercase to lowercase. If you say s dot upper, it will convert all lowercase to uppercase, and so on. There are other fancy things like s dot title. So title will capitalize each word. So this is how it normally appears, say, in the title of a book or a movie. S dot swap case will invert lowercase to uppercase and uppercase to lowercase, and so on. So there are a whole collection of functions in the string thing which deal with uppercase, lowercase, and how to transform between these. The other thing that you can do with strings is to resize them to fit what you want. So if you want to have a string which is positioned as a column of a certain width, then we can say that center it in a block of size n. So what this will do is it will return a new string which is of length n with s centered in it. Now by centering, what we mean is that on either side there will be blanks. Now instead of blanks, you can put anything you want, like stars or minuses. Okay, so you can give a character which will be used to fill up the empty space on either side rather than a blank. Now you may not want it centered, you may not want it to the left or the right. So you can, for example, left justify it using ljust, or r justify it using rjust, and again you can give an optional character and so on. Right? So we can just check one or two of these just to see how they work. Suppose we take a short string like hello, and now we center it in a large block of, say, 50. So we say s dot center 50. Then this gives us hello with a lot of blank spaces on either side. Now we can replace those blank spaces by anything we want. So say minus sign, then we get a string of minus signs or hyphens before that. Now we can also say that I want the thing left justified in this, not centered. So if I do that, then I will get hello at the beginning and a bunch of minus signs. Similarly with r just and so on. So some of the other types of functions which you find associated with strings are to check properties of strings. Does S consist only of the letters A to Z and capital A to capital Z? So that is what S dot is alpha says. Is it an alphabetic string? If it is true, it means it is. If it is not, it has at least one non-alphabetic character. Similarly, is it entirely digits? Is numeric will tell us if it's entirely digits. So there is a whole huge number of string functions, and there's no point going through all of them in this thing. We will, if we need them as we go along, we will use them and explain them. But you can look at the Python documentation, look under string functions, and you'll find a whole host of useful utilities which allow you to easily manipulate strings. And this is one of the reasons that Python is a popular language, because you can do this kind of easy text processing. So you can use it to quickly transform data from one format to another, and to change the way it looks, or to resize it, and so on. So string functions are an extremely important part of Python's utility as a glue language for transforming things from one format to another.